Friends, in this video, I am discussing the concept of pH and its importance in daily life. The idea of pH was introduced in 1907 by Sørensen, a Danish chemist. pH was meant to represent the hydrogen ion concentration of a solution and to give a convenient scale of acidity. Its importance was soon recognized to represent a wide range of concentration of hydrogen ions from 1 molar to 10 to the power of minus 14 molar found in several systems in daily life. Sørensen defined pH as given in equation 1 below. pH is equal to minus log CH plus to the base 10, where CH plus is the concentration of hydrogen ions. pH can also be written as pH is equal to minus log CH3O plus to the base 10. In aqueous solution, H plus ions are associated with water molecules and exist as hydronium ions, H3O plus. Therefore, both the equations 1 and 2 are true. For example, the concentration of H3O plus is equivalent to 1 molar. Then pH is equal to 0. On concentration of H3O plus is equal to 10 to the power of minus 14 molar. Then pH is equal to 14. Therefore, the pH scale is given in the range of 0 to 14 to relate the concentration of hydrogen ions in aqueous solutions in daily life. Please remember, pH is only a number. It does not have any unit. Let us see what happens when water acts as both acid and base in the same reaction. The resulting equilibrium is H2O acid plus H2O base, giving rise to H3O plus ions acid plus OH minus ions base. At equilibrium, the product of H3O plus and OH minus is equal to Kw, where Kw is the ion product constant for water. At 25 degrees Celsius, Kw is equal to 1.0 into 10 to the power of minus 14. Please remember that pure water is neutral. That means the concentration of hydronium ions is equal to the concentration of hydroxyl ions is equal to 10 to the power of minus 7 molar. Therefore, pH of pure water is equal to 7 as per the formula given in equation 2. See here, in this figure, you can see variation of pH with change in concentration of hydrogen ions and also hydroxyl ions. pH scale is the scale developed to measure the concentration of hydrogen ions in a given solution. The pH of a neutral solution is 7. A solution is said to be acidic if its pH is less than 7. A solution is said to be basic if its pH is greater than 7. Now, let us see the significance of universal indicator for measurement of pH. A universal indicator is a pH indicator and is a mixture of different types of indicators. It exhibits different colors at different pH values of aqueous solutions. It is used to detect the acidic or basic nature of a solution. It can be in the form of a paper strip or a solution. You see here, I have shown the universal indicator paper in the range of pH 1 is equal to pH 14. One can see the variation of the color of the universal indicator paper when dipped in solutions of different pH values ranging from pH 1 to pH 14. You can observe different colors when the pH of the solution is different. Worked out problems for calculation of pH of strong acids and strong bases. Strong acids and strong bases are the substances that dissociate completely in water. In such cases, the concentration of acid or base can be taken as the concentration of H3O plus ion or of OH minus ion respectively. Problem 1. Calculate the pH of a solution of 0.01 molar HCl at 25 degrees Celsius. Solution. The given that the concentration of HCl is equal to 0.01 molar. HCl is a strong acid. Therefore, the concentration of H3O plus ions is equal to 0.01 molar. Square bracket indicates concentration. The formula to be applied is pH is equal to minus log CH3O plus to the base 10. Therefore, pH is equal to minus log 10 to the power of minus 2, that is equal to 2. Problem 2. Calculate the pH of a solution of 0.02 molar NaOH at 25 degrees Celsius. Solution. The concentration of NaOH is equal to 0.02 molar, that is given. Therefore, the concentration of OH minus is equal to 2 into 10 to the power of minus 2 molar. We know that the concentration of H3O plus multiplied by the concentration of OH minus is equal to Kw is equal to 1 into 10 to the power of minus 14. Therefore, the concentration of H3O plus you can calculate and it gives you 0.5 into 10 to the power of minus 12 molar. Therefore, pH is equal to minus log of 0.5 into 10 to the power of minus 12, that gives us 12.30. Note, in the case of weak acids like acetic acid and weak bases like ammonium hydroxide, their dissociation in water is incomplete. Therefore, their concentration cannot be directly used in the calculation of pH. You will learn the calculation of pH in such cases in higher classes. Now let us see the pH values of a few aqueous solutions of substances used in daily life. For example, lemon juice pH is equal to 2.2 to 2.4. Tomato juice pH is equal to 4.2 to 4.4. Black coffee 4.85 to 5.10. Black tea 4.9 to 5.5. Gastric juice 1.5 to 3.5. Milk of magnesia 10.5. Pure water pH is equal to 7.0. Fresh milk 6.5 to 6.7. Baking soda, if you take 1% solution, pH is equal to 8.5 to 9.0. Importance of pH in daily life, let us discuss now. pH of the human body is between 7.35 and 7.45. Human body works well within this pH range. Number 2, pH of rainwater of highly polluted cities is between 4 and 5. Then it is called acid rain. If this acid rain enters into rivers or lakes, it causes danger to aquatic life. Acid rain has several other harmful effects on humans and other living species. It also corrodes buildings and bridges. Number 3, pH of gastric juice produced in human stomach ranges between 1.5 and 3.5. This is because of hydrochloric acid produced inside the stomach, which activates an enzyme and helps in digesting food. If the pH is less than 1.5, it leads to the problem of ulcer in the stomach. Milk of magnesia, that is magnesium hydroxide, is used to neutralize the excess acid. Number 4, pH of the soil. Most of the plants grow well in a soil with a pH in the range of 5.5 to 7. Therefore, the pH of soil is important in agriculture and horticulture. Then 5, role of pH in decay of the tooth. Tooth decay starts when the pH of the mouth is lower than 5.5. Bacteria present in mouth produce acids by the degradation of food particles left in the mouth after eating food, and the pH becomes less than 5.5. Therefore, After eating food, we have to clean the mouth thoroughly, besides brushing teeth early in the morning daily. Number 6. Self-defense by animals and plants. For example, when a honeybee stings, it leaves an acid which causes pain. That is a self-defense mechanism in a honeybee. If a mild base like baking soda is applied on the stung area, it gives relief. Stinging hair of nettle leaves inject methanoic acid, causing burning pain. pH of fresh milk and curd. pH of fresh milk ranges between 6.5 and 6.7. As it turns into curd, the pH is reduced to 4.5 to 5.5. This is because lactose present in milk is converted into lactic acid by the action of bacteria. Application 8. Addition of baking soda to fresh milk. Many milk vendors add a small amount of baking soda, that is sodium hydrogen carbonate, to fresh milk to increase the pH of milk and delay its conversion into curd for a relatively longer period. Self-assessment test. Calculate the pH of 0.001 molar HCl. Calculate the pH of 0.001 molar NaOH. Calculate the pH of 0.005 molar HCl. Calculate the pH of 0.002 molar NaOH. Write the mechanism of self-defense of nettle leaves. Write the mechanism of self-defense of honeybee. What should one do when he or she is stung by a honeybee? Define pH. Explain pH scale and its usefulness in day-to-day life. Explain universal indicator and its usefulness in day-to-day life. Write the mechanism of conversion of fresh milk into curd. Explain the pH range in mouth as the cause of tooth decay. Explain the role of pH in our digestive system. Explain the role of soil in the growth of the plant. Now, let us see a few multiple choice questions also. The pH of human body is in the range of A. 6.35 to 6.45, B. 8.35 to 8.45, C. 7.35 to 7.45, D. 7.0 to 8.0. Question 2. The pH of the gastric juice produced in the stomach is in the range of A. 1.5 to 3.5, B. 2.0 to 3.0, C. 2.5 to 3.5, D. 3.0 to 4.0. The pH of 0.002 mHCl is A. 2.00, B. 2.30, C. 2.70, D. 2.90. The pH of 0.005 molar NaOH is A. 5.70, B. 7.70, C. 9.70, D. 11.70. The pH of 0.0005 molar HCl is A. 3.00, B. 3.30, C. 3.50, D. 3.70. 6. The pH of 10 to the power of -10 molar NaOH is A. 10, B. 8, C. 6, D. 4. Thank you very much.